Welcome to the topic of experiment. In this topic, we will be learning about two types of techniques: methods for collecting gases and methods to purify and separate mixtures. Now, there are various methods for collecting gases, and the method depends on how soluble the gas is in water and how dense the air is compared to air. Now, what does it mean when something is denser than something? For example, X is denser than Y. Now, key in your answer in the question box that will appear. Well, if you remember this movie Up, the balloons are less dense than air. And let's look what happens.
Afternoon.
So they float. So let's look at our first method in collecting gases, the downward displacement of water. Now, it is used for collecting gases that are insoluble or very, very slightly soluble in water. Well, if the gas is soluble in water, it will dissolve and you can't collect it. So gases that do that are like carbon dioxide, hydrogen, and oxygen. So what happens is that you have a basin or beaker full of water and an inverted gas jar where gas is bubbled into it. The following video shows you the same thing but with an inverted test tube instead of a gas jar instead.
Collecting gas over water is an efficient way of obtaining small samples of gases in the laboratory. It works well for any gas which does not dissolve in water easily. For this demonstration, I am going to react hydrochloric acid with magnesium, which of course produces hydrogen gas. The beaker acts as a water reservoir in which there are two upturned water-filled test tubes. If one of these tubes is placed over the end of the delivery tube, every bubble of gas can be seen as it is produced. As soon as a tube is full, gas bubbles begin to escape into the reservoir once again. This enables the user to choose when to replace the tube with another.
The next method is used for collecting gases that are soluble. Hence, you can't use the same method as the first one. And it's specifically used to collect gases that are denser than air, for example, chlorine or hydrogen chloride, HCl. So you bubble the gas downwards into a gas jar. As the gas is denser than air, it will remain in the gas jar. For gases that are less dense than air, we do the reverse. For example, ammonia. So we are looking at an inverted gas jar. So we bubble the gas upwards, and as the gas is less dense than air, it will not sink downwards from the gas jar, but it will remain in the top of the gas jar, as it will in a sense float on the top of the air surrounding it. Now, you notice in the first three methods, you're able to collect the gas, but not able to measure the volume of gas. So if you do need to measure the volume of gas, you can connect it to a gas syringe instead. But do note that gas syringes are only made in small sizes usually, so you can't use it to measure large volumes of gas. Next, we'll have a quiz, so key in your answer in the question box that will appear. Now, we have a summary now of the ways to collect various gases. Now, there's just one thing to note. As hydrogen is less dense than air, it can also be collected via outward delivery. So it can be collected by two methods, the displacement of water and outward delivery. Similarly, carbon dioxide is denser than air and can be collected via downward delivery as well. Now, one more thing about the collection of gases. As the gases we obtain may contain water vapor, especially in such humid Singapore, after collecting the gas, you will pass it through a drying agent. So these are the three drying agents you need to know, and we'll go through it in turn. So the first one, concentrated sulfuric acid. As it's a solution, the gas has to be bubbled directly into the solution. It is suitable for most gases except ammonia. Now, why do you think this is so? Think about acids. What do acids react with? Now, next is calcium oxide. Now, this is good for drying ammonia, as ammonia is less dense than air. So you bubble it upwards, and the ammonia will naturally float outwards through the calcium oxide. In this case, ammonia does not react with calcium oxide. The last one is dry with fused calcium chloride. Now, this is used to dry almost all gases because calcium chloride, if you remember, is a salt. It's not an acid, it's not a base. So most gases will not react with it. So what you do is that you bubble in the gas on one end and it will go out the other end. Now, a short quiz to recap what we have learned. And that's the end of the video.